Hey guys, happy Wednesday. Today is May 6th. This is for Math 1. We're going to be talking about investigating the b-value and exponential functions. We talked a little bit about it, but not too much, okay? So let's just first start off with what we already know. So in an exponential function, the first thing we already know is remember that this a is the y-intercept. You can also call it the starting value, or you can also call it the zero term, right? And then remember this b value, that is my multiplier. That's how much it's growing by, but instead of growing by adding, it's growing by multiplying. So we kind of have two different situations that happen with our b value. The first situation looks like this. So when my b value is greater than 1, meaning like 2 or 1.5 or 1.7 or 10,000, any number bigger than 1, it's going to be increasing, and we call that growth, a growth function, because obviously it's increasing. If my b values are in between 0 and 1, now the reason why I say in between 0 and 1 is because I'm not talking about negatives here. I'm talking about numbers that are smaller than 1, but not negative, like a half or 0.8 or 0.3 or 0.17 or 3/4, anything smaller than 1 but greater than 0. So not negatives. Then our graph ends up being decreasing. So this is not talking about negatives. It actually makes it decrease when my values are smaller than 1 but not negative, okay? So we call that a decay function because it's decreasing. Okay, so these are two types of functions. So let's look at some examples here, okay, so we can kind of see what's going on. So here I have an example with 3 different situations, and we're going to compare them to see what else is going on with our b values. We already know that when it's greater than 1, it's increasing, and when it's in between 0 and 1, it's decreasing. We want to see what else we can find out, okay? So we're going to go ahead and substitute in just like we did yesterday and fill in our tables. Now, real quick before we start, I want to make a note. Remember, when there's no number in front here, we talked about this yesterday, it's not 0, because if it was 0 times something, that would give me 0. It's a 1 that's right there in the front, 1 times. So that means that my y-intercept is going to be 1. And then this is my multiplier, so it's going to be multiplying by 1.2 every time. So I'm going to times by 1.2 here. That will give me 1.2. And I'm going to times by 1.2 again. It gives me 1.44. And then remember to go backwards, I would divide by 1.2. So 1 doesn't divide evenly by 1.2. So approximately 0.83. Not exactly, but approximately. And then divide again by 1.2. You get approximately 6.69. Again, just approximately. Remember, you could also just take 2, 1, 0, -1, and -2 and plug them in for x here to find all of them. That's another way of doing that. Okay, so let's go ahead and graph this, okay? So at -2, that's over here, -2, I'm going to go to 0.69. This is going to be like super close to 0, like you almost on the 0. Down here. I'm sorry, you can't even see. Down here, super close to the 0, -2. -1 is 0.83, still super close to 0. Okay, then 0 is 1, and if this is 5, then that means that this is 2.5, so 1 is still pretty close down here. Now you might be saying, why did you make your graph go up to 50 if your number only goes to 1.44? Because I want to compare all 3 of these to see what happens, okay? So then I have at 1, it's 1.2, still way down here. At 2, it's 1.44, that hardly moves at all, still way down here. And I'm going to go ahead and just keep going. I know we didn't make our table, but I want you to see this, okay? So 1.44 times 1.2 again gives me 1.728. So again, it's like still pretty flat. All of this is still pretty flat. And times 1.2 again, that's a 2.03. So then still pretty flat here. It's going up a little bit at a time. times 1.2 again, 2.4. Now we're in the middle of the square finally. Times 1.2 again at 2.9, just above that. Times 1.2 again at 3.5, going up little by little. Times 1.2 again, we get 4 points, still not even to 5 yet. So you see how slowly this is growing? It's growing so slow. Times 1.2 again, finally get past 5. So I don't even pass 5 until I'm all the way out here. So see how this is growing so slowly. If I try to graph it together, it's gonna look like this. I'd be going off this way. And it's going to eventually curve up like this, but not for a while. I'd have to make a humongous graph to see that, okay? Let's look at the second one and see what happens there. So for the second one, that one's 4 to the x. Again, remember that there's a 1 times in front of that, so that's your starting value, 1. Put my value at 1 down here, starting value at 1. And again, I'm going to multiply by 4. So times 4 here gives me 4, times 4 again gives me 16. Divided by 4, to go backwards, gives me 1/4 or 0.25. And divided by 4 again gives me 1/16 or 0.0625. Super small. Okay, so I'm going to go backwards first. So -1 is 0.25, -1.25, super small all the way down here. And then -2 is 0.06, that's even smaller, all the way down here. Okay, and then 1 is 4, so that's kind of like here-ish, because 1 is 4. And then 2 is 16. 16 is up here, so it starts going up. Okay, so if I connect that together, it's gonna look something like this. Now I want you to notice just already with these two that we just did, look at this, how far I went out here. I went out 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, and it still wasn't even hardly curving up yet. It was still like in this part right here. Versus this one, where the B value is bigger, this is 1.2, the B value is bigger, it started curving pretty much at 1 already. See the difference there? This is a super long curve. My B value is smaller. Okay, so let's try another one. Okay, so let's do the same thing here. Again, there's a 1 times in front of it. So the one y-intercept is 1. So I'll put it at 1 here. And then I'm going to multiply by 10 to go forward. That's obviously 10. Multiply by 10 again. That's 100. To go backwards, I'm going to divide by 10. So I'm going to get 1/10, which is 0.1. Divide by 10 again, and I get 0.01. So let's go ahead and graph. So 0.1, it's like all the way down here at -1. -2, it's even closer, all the way down here, super small. At 1, it's at 10 already. Look how big it jumped already there. And at 2, I can't even graph that. This is only halfway. So kind of it's going to be like here-ish, like as I'm going through. Okay, so I'm going to graph those together, connect it all. So I want you to look at these 3 graphs. Look at what happens. This one turns already way sooner than this one does. So changing from 1.2 takes forever to go up. Then changing to 4, my multiplier, it goes up faster. Then changing to 10, it goes up even faster. So the bigger my B value is, the faster it increases. Okay, let's write that down. So the bigger B value, the faster it increases. Which makes sense because obviously, like if I'm doubling something versus multiplying by 100, obviously timesing by 100 is going to go up really fast. Okay. All right. So 2 things to remember: the bigger the B value, the faster it increases. And then also to remember that B values that are greater than 1 are increasing, and B values that are in between 0 and 1 are decreasing. If you have any more questions, feel free to let me know. Talk to me through Remind, email, Google Classroom, whatever you need. Have a great day, guys.